Hello, my name is Christian Mena, and this is Group 2 presentation on Chapter 16, Enable Feedback so Development and Operations can safely deploy code. Another members of the group is Mackenzie Taggart and Hugo Vera. So with this, one of the first examples that we can explain is the Right Media. It's an online advertising platform. And one of the biggest challenges that they have as a company was getting the developers um, deploy their own code, um, and to separate the groups for testing and deployment were too slow. So they saw that having a group of testing and a group of deployment, the deploy of the code was too slow because they have to go through the whole process of testing and deploying at the same time. And the developers didn't want to deploy their own code; they were afraid to do it. So one of the solutions that they found was to integrate all these product functions into one group with shared responsibilities and goals, and also to deploy smaller pieces of code um, into the production platform. They will see that it will cause fewer problems into the production environment. So the secret to smooth and continuous flow is making small but frequent changes that anyone can inspect and easily understand. Now, another thing that it was important, it was for them to use the telemetry to make deployment safer. And this what basically means is that uh, developers and operations are actively monitoring production telemetry when performing production deployment to ensure that the services don't break or any other services break when they have deployments. The goal is to catch errors in the deployment pipeline before they get into the production. And relying on production telemetry can help restore services when non-detected errors occur. And this fixing can be done by turning off broken features with feature toggles, um, by fix forward or rollback. So when the operation development side deploying a piece of code, they use telemetry to see how the deployment is affecting the production environment. And if they see there's something's going on, causing a problem with the server, or one of the APIs or anything like that, they can um, fix the problems by switching maybe one of the servers or restoring one of the servers, maybe fixing the a code into the production environment. And I've seen this as sometimes a script may be broken, it's not doing what it's supposed to. So a developer can be in teaming up with operation engineer to see that issue, and the developer can fix fix the script and into the production environment. Or if this causes too much issue, the new piece of code they can roll back and basically take um, the new deployment, take it back and reinstall the old piece of code that was working prior to the deployment. Now, another thing that was important for them, it was the developer shares pager rotation duties with operation. And um, in any complex service can have unexpected problems. And if left unfixed, it can cause issues and suffering for operation downstream. So the main solution for this problem, it was that everyone in the value stream needs to share the downstream responsibilities in handling operation incidents to ensure that everyone gets feedback on any upstream architectural and coding decisions. As consequence of sharing responsibilities, the feature is done when it's performing as designed in production. So developers and operation engineers can share these responsibilities of deploying code into the production environment. So whenever they have that responsibility of deploying and watching for that deployment, they can receive the feedback that they need to see how that new deployment is working in the environment, receive feedback to see if the code is broken or it wasn't um, performing as it was supposed to perform in the production environment. Once everybody is getting the feedback that they need and seeing how the deployment is um, working into production and the behavior is the one that is expected, um, that will be a successful deployment where everybody share the same responsibility. Another important thing is that assign developers to follow work downstream to the end user deployment. And one of the better methods to improve the application is the opportunity of the developers can have to see a customer using the application in their natural environment. By doing this, well, we can have the following advantages. One, developers can see how the downstream work uh, centers work. They can also see how the customers encounter difficulties firsthand, and they can make better and more informed decisions in their daily work. And developers can create feedback on non-functional aspects of their code. So if the developer see and follow writes a piece of code and follow that code and see how that's affecting the production environment and how the customers are interacting with his change or his deploy, he can better understand how the customer experience on what he fixed or what he deployed, a new deployment, so he can better make better informations in the future or make better decision in the future um, that will affect the customer experience. Also, developers initially they should be self-manage the production service, and to prevent problems in the self-managed service going into production and creating organizational risk, we need to define launch requirements, and it may include the following: defect counts and severity, tab frequency of page alerts, monitoring coverage, system architecture, deployment process, and production hygiene. All of those things can developers help um, and self-manage position to help in the production service to the operation engineers as well. And one of the examples of this is Google. They created a system where developers are self-managed, and before going to production, they have two critical stage that they can review and see how uh, the the new deployment is going to affect the production environment. And usually it takes about 6 months. They self-manage to go in the production, and they have site reliability engineers. They can value in the deployment and give advice to the project teams in an early stage. Then the second phase will be the launch readiness review, where they can self-report by the product teams, and they can complete it before service are made available to the public to the customers and receive live production traffic and assign. And they're gonna have an assigned site reliability engineer through the whole process to see and to follow up um, the project itself. And the last one stage, the last stage, it will be the handoff readiness review, and that happens months after the launch readiness review, and they perform when the services is transitioned to the operation managed state, and it is followed again by the site reliability engineer. And in conclusion, one of the important things is the feedback mechanism that improve service of the daily work are smart deployed changes into production, which by having a small deployments of code into production, it can be easily detected and easily fix. Page engineers to fix code when things go wrong, and that's something that is shared in conjunction with the developers. The also developers should follow the work downstream to see how their work is affecting the customer in first hand, write more production ready code, and sending problems back to the developers to fix. And this is our presentation for chapter 16 on group 2. Thank you.